We are still talking about trigonometry, okay? But today we are going to discuss sine rule or sine law, okay? So let's see how we can use this rule. And the rule is here: sine A all over small letter a is equal to sine B all over small letter b is equal to sine C all over small letter c. Or you can say sine A all over small letter a is equal to sine B all over small letter b, and also sine A all over small letter a is equal to sine C all over small letter c. Or you can even take sine B all over small letter b is equal to sine C all over small letter c. Okay, now this law or rule is normally used in a triangle that is not right angled triangle. Okay, so example of such triangle is what we have here. Okay, now normally in a triangle we use capital letter to represent the apex here, and also this capital letter we have here is also the angle that we have in the triangle. Okay, like in this place, since here is capital letter B, the angle here, the angle formed here is also capital letter B. So that is what we call this angle. So in this place, the angle here is A, and here the angle here is C. Okay, now we normally compare the angle formed here with the side opposite to that angle. So look at it here. So the side that is corresponding to this angle is this one. That is why we call this side small letter a, because we normally use small letter a to represent sides in a triangle. Okay, so this angle, the corresponding side is this one, whereas this angle, the corresponding side is this side, this one that is opposite to it. So look at it here. And in this one, the corresponding side of this angle C is this one. Okay, now if I have a triangle this way, and I have let me say X, Y, Z here. Now if I want to label the sides of this triangle, then look at where I will label small z, because this is where capital letter Z is, which is the angle Z is here. So the small z will now be here. Okay, now for this side, since our angle here is X, capital letter X, then we will now follow this way. Okay, so here will now be small letter x. Then for this side, since our angle here is capital letter Y, then the corresponding side here, which is the side that is opposite to this angle, will now be small letter y. So this is small letter y. Okay, that is what or how we use this law or rule. Okay, so this rule here, you have to memorize it. You have to know it very, very well. Now let's see how we use it in solving problem. So we have example here in triangle ABC. Side A, I call this side A because it is a small letter. So we normally use small letter to represent sides in a triangle. So side A is equal to 7.1 cm and side B is equal to 9.5 cm, and angle at B is equal to 63 degree 18 radians. Okay, now solve the triangle completely. Okay, so what do? First of all, we have to change everything here into degree, because we have some part of it that is in degree, we have part of it that is in radians. Okay, so we have to convert everything to degree. Okay, so how do we do that? Now look at the conversion factor. 63 degree 18 radians means 63 plus 18 radians. Okay, now we have to convert this radian into degree. Now we now say the conversion factor is that 1 degree is equal to 60 radian. Okay, so since 1 degree is equivalent to 60 radian, then what degree will now give us 18 radian? Okay, so we are going to do cross multiply here. Now 60 times x is what we have here, and 1 degree times 18 radians is what we have here. Okay, now let me do it here. So what we have here is 1 degree is equal to 60 radian, and x is equal to 18. So we have to do cross multiply so that we have x times 60 is the same as 1 degree times 18. Now for us to find the value of x alone, we have to divide both sides by 60. So 60 cancel here, we have only x, and 1 times 18 is 18, then divided by 60 is 0.3, and that is what we have here. So x is 0.3. It means that the equivalent value of 18 radians in degree is 0.3 degree. So we will now add this 0.3 to 63, to this 63 degree, so that we now have 63 degree 0.3. Okay, so that means that 63 degree 18 radians is equivalent to 63.3 degree. Okay, it's equivalent to 63.3 degree. Now we can now continue. That means that we have converted this angle. That means angle B now is now equal to 63.3 degree, and that is what we'll be working with anytime we want to call for angle B. Okay, so let's now come to this triangle. Now remember that we have side A is 7.1 cm. So side A is the side that is opposite to this capital letter A. Okay, so that here will now become 7.1 cm, and we have side B is 9.5 cm, so that since we have our B here, then the side B will now be this side, which is 9.5 cm. Okay, now If you don't have this diagram already and you want to make your diagram from the equation, what you will just do is you follow the equation. Like in this place we have in triangle ABC. So you just have to draw your triangle. You just label. You can even start here A, B, C. Okay. Now side A is 7.1. Now since you label here A, capital letter A, then side A will be here, which means here will be 7.1 cm, and also side B is 9.5 cm. Okay, so that since here is B, then look at side B here, which is 9.5 cm, and angle at B is 63 degree 18 radians. So angle at B, look at B, angle that is formed here is 63 degree 18 radians. Okay, so this diagram is the same as what I have here. Okay, so just follow your labelings very well. Okay. Now we have actually changed the degree we have here. Instead of 63 degree 18 radians, we now replaced it with 63.3 degree, because that was what we got when we changed 63 18 radians into degree. So we can now start our solving properly. Now let's begin to compare the angles and the sides. Let's begin to compare the angles and the side. Okay, so we have B, angle B, so we say sine B all over small letter b. Okay, then we will compare it with the side, any other side that is given. So look at the side we are going to compare it with, this side, so that we can now use this side to find this angle, because we were told to find this triangle completely. That means we are going to find the value of C and this angle A and also angle C. We are just going to find everything in this triangle. Now since B is given to me, I will say sine B upon the side B, because the side B is also given to me. Now I will now equate it to the side that is given. So I will now say sine A then upon side A, which is 7.1. Okay, that is where I will start with. So you just check the sides that is given, or the sides that are given. So we have two sides here, and we have one angle. So you just start with this angle and each side. Now compare it with the side that is given and its angle, so that you can use it to find its angle. Okay, now what I have here is the same as what is here. Now in this place, sine B is now sine B. Remember that B is 63.3. So sine 63.3 all over small letter b is 9.5. 9.5 is equal to sine A. Sine A is what? Sine A is, we don't know sine A, so we just write sine A all over 7.1, which is side A, okay, all over 7.1, and this is the same as what we have here. So we can now start from here. Now if you do cross multiply, because we are looking for the value of A, you now have sine 63.3 times 7.1 will give us this, and sine A times 9.5 will give us what we have here, sine A times 9.5, okay? Now, since we are actually looking for A, since it is A that we are looking for, we need to first of all remove this 9.5 here, and we do that by dividing both sides by 9.5. So if we divide sine A times 9.5 by 9.5, we equally divide 7.1 times sine 63.3 by also 9.5, okay? So that this will cancel this now. So when we do that, we will now have that sine A is now equal to 7.1 times sine 63.3 all over 9.5, and that is what we have here, okay? Now, sine 63.3 is what you have here. Sine 63 is 0.8933. So if you multiply this by 7.1, you will now have, and then divided by 9.5. If you do 7.1 times 0.8933, then divided by 9.5, you have approximately 0.6676, okay? Now remember that what you have just found is only sine A. Now for you to find only A, you have to do sine inverse of what we have here. So sine inverse, we now do sine inverse of 0.6676, so which is second function sine 0.6676. It will give you 41.882, approximately 41.88, and that is what we have here, okay? But our angle was given to us in degree radians, so we have to change this 41.88 degree to degree radians, okay? Now remember that 1 degree is equivalent to 60 radian. Then here, this is 0.88. This is the one we are going to change into radians. So since 1 degree is equal to 60 radians, then we will now say 0.88 degree will be what? Radians, okay? So because from here now is what we will take from the decimal number part, which is 0.88. We will convert this decimal number part to radians, okay? So that we will now do cross multiply. Now 1 degree times x will be equal to 0.88 times 60 radian, so that if we now divide both sides by 1 degree, now this degree will cancel the degree here, then x will now be 0.88 times 60 radians, and that is what we have here. So that instead of writing 41.88 degree, we will now write 4160 times 0.88, which is what I have here. Then if you multiply it, 60 times 0.88 approximately will give you 53, so that everything will now become 41 degree 53 radians, okay? Now we have found the value of A. Okay, so we have found this place. I will use the degree value. So in degree value, here is 41.88. Remember, we were told to find the triangle completely. That means we are finding everything. So it's now left for us to find the value of C, angle C. Now we are going to use sum of angles in a triangle to find the value of C. Remember that in triangle, all the angles in a triangle sum up to 180 degree, and that is what we are going to do here. So angle at C is equal to 180 degree minus the sum of these two angles, okay? That is what we have here. So that if you sum this and take it away from 180 degree, it will now give you 74.82 degree, okay? Now, since our value was given to us in radians, now we have to also change this 74.82 to what? Radians. So we are going to convert this 74.82 to degree radians because our value of angle was given to us in degree radians, just like what we did here. 0.88 gave us 53. We multiplied 0.88 by 60 to convert it to radians. The same thing is applicable here. This thing means 0.82. So we just multiply this 0.82 by 60 to change this part to radians. So that is what we have here. So 60 times 0.82 will give us approximately 49. So we now have that 74.82 will now give us 74 degree 49 radians. This is the degree part of it. This is 74 degree. Then the decimal part of it will convert it to radians, and that is what we have here. So it will now give us 74 degree 49 radians. Okay, so we have found this angle. We have found this angle to be, I will use degree part here. So in degree, here is 74.82. Okay, so now left with side C. Okay, so for us to find side C, we are going to use sine rule in this side C. Okay, let's find side C. Okay, let's find this side. Okay, so for us to find side C, we will compare this side C with angle C, which is sine 74.82. Okay, so we'll now say sine 74.82 upon side C, which is equal to, we can choose any angle here. We can equate it with either B, angle B upon side B, which is sine 63.3 upon 9.5, or we can equate it to side sine 41.88 upon side 7.1. So anyone we choose. Okay, but let's take sine 63.3 upon 9.5 because they are complete. Okay, so we'll now say equal to sine 63.3 upon 9.5. Okay, now for us to find side C, we have to do cross multiply so that C times sine 63.3 is equal to sine 74.82 times 9.5. Okay, before then, let's make side C the subject of the equation by dividing both sides by sine 63.3. Okay, so if we divide both sides, we will now have sine 63.3 is equal to sine 74.82 9.82 times 9.5 divide through by sine 63.3 sine 63.3. So this will cancel this. So we now have C is equal to sine 74.82 times 9.5 all over sine 63.3. Okay, now sine 74.82 times 9.5 is equal to 9.1685 approximately, divided by sine 63.3 is 0.8934 approximately. This is side C. Okay, that means that side C is equal to 9.1685 divided by 0.8934, okay, which is 10.2624. 262. Okay, because of this 8 we'll take 5, okay, approximately to become 2625. So C is equal to 10.3 cm to 1 decimal place. Okay, so finally the angle at A is equal to 41 degree 53 radians. Then angle at C is equal to 74 degree 49 radians, and side C is equal to 10.3 cm. Okay, thank you.